¿Cómo estás, mis amigos? Mr. Stone here, and it's time to do some math rock and roll. Today we're looking at the law of sines, the ambiguous case, and complete with stick dog schnauzer, because schnauzers are cool. So let us say that we've got a scenario where you are given a few bits of a triangle. You are given that one of your angles is 38 degrees, big A. Little a, the side that is across from that, would have a length of 14. And another side, called little b, would have a length of 20. You want to determine what is the angle that measure that is opposite of little b. Well, this seems simple enough. I would set it up. How? Use your law of sines. Sine of 38 over 14 equals sine of big B over 20. Algebra that out. You get 20 times the sine of 38 over 14 equals 0.8795, rounded of course, but that is for the sine of b. We want to get b by itself, so big B, that is, inverse sine of 0.8975 gives us 61.58, which is approximately 62 degrees. I like that. So we feel that this is awesome. We feel that we are set, and we can check our work here. If the law of sines is holding true, the sine of 38 over 14 would equal the sine of 62 over 20, which in this case both of these are about 0.044. But this also happens to be the sine of 118 over 20. What? Well, here's the thing, my friends. This sine of 62 can be interplaced with the sine of 118 because they are the same thing. That's right. Get out your calculators. You better believe it. The sine of 62 and the sine of 118 are the same thing. Both are approximately equal to 0.8829. Wowzers. So what does this mean when I'm making my triangles? Have I done everything wrong? Is the universe falling to shambles right before my very eyes? Not the case, my friends. It is just an ambiguous case. Yes, I just said the title of this video. Who would have thunk? So what this looks like is something like this. I've got a triangle here. This is a 38-degree angle. This side we can say is 20. And then I've got the other side over here, which would be 14. This happens to be nice, and 62 is in our first case. This goes there. We're happy. This is the world that we know. However, this is not always the case, for we can still have the same setup here with a length of 20, an angle of 38 degrees. But now, my friends, we go over here. We extend that away, and this angle measure is 118 degrees. It works, and this is still 14. Why? Because the sine is somewhat circular. In fact, there is a thing called the unit circle, which will tell us that we will have two values for where our sine of these angles will equal the same thing. But I don't have the unit circle down right now. What do I do? Well, think of it this way. If you are figuring out an angle and you get something such as our case right here. I've got 38 degrees for big A, and then my calculator tells me that I've got 62 degrees. Think of this. Your calculator will only tell you one thing. However, if you check by taking whatever you happen to get and subtracting it from 180. So I take 180 minus 62. That gives me 118 degrees. That happens to be exactly what I've got right there. If you can take 38 plus your original angle, that gives us 100, then we still have room for a third angle, which in this case would be 80 degrees. If we can do that over here as well, so if I take 38 plus 118, that gives me 156. I still have room for a third angle that is 24 degrees. That's the check, my friends. If you can put together whatever your angle is, and whatever your calculator gives you, subtract that from 180, just like right here. If you have another angle measure that you can combine with your original angle that you were given, and you are less than 180, then you've got a situation where you've got a flipping triangle here. And I say that because you can, let me change colors up. Look at the triangle on your left. You can flip this guy in here, and here is 118, or you go with the larger case on the outside. Again, this is the ambiguous case where sometimes you will see two possible angle measures if you are not given that particular angle. And if you're doing it visually, if you've got that diagram before you, you should be able to interpret it, see very clearly, hopefully in most cases, whether it is an obtuse or an acute angle. If it is something very close to 90, well, in that case, look very, very closely, my friends. All right, again, this is the law of sines, the ambiguous case, complete with awesome stick schnauzer. It doesn't get any better than this. Think if you have questions. We will move forward. You will continue to be awesome. Have a most excellent day.